So we'll get started. So I'll do some quick introductions. I'm Corey Battle. I'm the CEO here at BuildingPoint Mid-America. Kevin?
Hey, I'm Kevin Kaufman. I am the hardware sales manager here for BuildingPoint Mid-America.
And my name is Bob Groen. I'm the hardware sales representative for the states of Missouri and Arkansas.
And my name is Sean Spencer. I'm the East Coast sales manager for Trimble.
And Sean's our new guest there. You can see he's normally caught wearing a HoloLens when outside of the house, but during quarantine, he's able to take that off. So, Sean, thank you for joining us today. So quick course outline. We're going to give a quick introduction. Then we will, as usual, we'll do some live demonstrations. Kevin and Bob both have a couple of live demonstrations to talk through. The first one's going to be Bob with shooting control points. He's going to go through measurement settings on the devices. I know some of this stuff we've already talked about before, but we're going to talk about it again because it was maybe taught by Sean a couple weeks earlier, and now we're showing you the actual application of that again. The other one's going to be setup angle and the sequence, and then Kevin's going to jump in with measure settings, measuring tools, and then he's also going to talk about reference elevation, and then we'll cover tips and tricks, Q&A, and we'll talk about what our next webinar coming up is. So the first slide that we've got here is a definition slide. Just wanted to kind of clarify a few things because I wanted to talk through a couple of definitions. So the first one is a point. So we talk a lot about points, control points, what's the point, getting to the point, different things like that. I want to clarify what a point is. So a point is just a place, an area, a rendezvous point, establishing location, verifying location before completion, or an as-built location. That's the way we're talking about a point in building construction. So that point could be where that dang it goes, or where that hanger needs to lie, or where that can light's going to be, or where that sprinkler head's going to be centered. A control point is a point, however, it's that controlling point. So it's a known non-variable measurement. So this is a given. Yes, you can come here, and then this is control point X, Y, Z. And then you'll have many of those across the site. Now, I do want to clarify there's building control points and civil control points. So your civil control points are also known as your first-gen control points. Those are surveyor-provided. So those are set up by a registered or licensed surveyor that shoots a traverse around the site when they set up those control points within the state coordinate system and state plane system to make sure that everything is set up on that site geospatially. A building control point, also known as a second-gen control point, is created off of either building corners or column lines or some kind of landmark. It could be an adjacent building. That is all referred to as a building control point, or again, a second-gen control point. Outside of that, you may also create additional control points, which may be lines and offsets and things like that, that it's not a layout point, but it is, in fact, just a tertiary layout point, if you will, to create layout offsets. A couple of things that we do want to talk about because we're focused specific on building construction, and that is vertical building tolerance. So I do want to clarify a couple of things, and coming from being a BIM guy myself, I understand this well. When you do model coordination, so spatial coordination of the HVAC, the plumbing, the fire protection, the structure, the concrete, everything in there together, it's always assumed by the authoring software that we're using that the building is completely plumb and is completely level. As we all know, that's an anomaly or an analogous resource that we will never get live. It's not reproducible. So nothing can always be super flat. Now, granted, you can get super flat concrete with a lot of work, but as we elevate, getting super, super flat and different things like that, but having a perfectly plumb building is almost nearly impossible, and that's because of many reasons. One of which can be as simple as just environmental conditions. It could be hot this day, and it causes the steel to move in differential settlement and different things like that. But on top of that, the specifying industries that are out there. So ACI controls the concrete standards. So the concrete standard allows for at maximum allowable variance out of plumb of 1 inch. And that's up to an 83-foot building. So just keeping in mind that that 1 inch is the maximum that it can be out. Now, that doesn't mean that it can't sway in and out as it goes throughout that. So just keep in mind, that's just the concrete tolerance alone. when we get to the Masonry Institute, so this is the International Masonry Institute standards, it allows masonry walls to be out no more than 1/2 of an inch if that wall is above 20 feet. So 20 feet and taller, it can be no more than 20 feet out of plumb. And that's perfectly acceptable. Now, granted, other specifications may override that, depending on what that is, but just understand the masonry tolerances that are set allow for that. AISC, Code of Standards Practice, and I actually pulled it out here, 7.13. This is the vertical building tolerance for structural steel. And again, this is pulled directly from the AISC standards, and it allows for, at maximum, up to 2 inches toward or 3 inches away from the building line, meaning that the building can lean towards or away from that building line by that percentage. And again, whether it's perpendicular or parallel, there are different tolerances there. So just keep in mind that that building floor can rack, and that's kind of what we've always called it, is it's racking from side to side within the construction industry. So when we talk about this, and we talk about building control points and civil control points, what we're trying to elaborate on, it's always important to have building control points at every level as you're working up. So in lieu of building an 8-story building and pushing somebody down to a civil control point down on the site, it's best to also have building control points. I'm not saying that the civil control points are off, but it's also a very, very extreme and requirement, if you will, to have building control points inside of that too. And the way I want to equate this, and this is something Sean taught me years ago, and that's if you can look at it as ships out at sea. So if you measure that ship and you measure it from a dock, depending on what time of day that you measure that because of the tides, that measurement's always going to change from the dock to that boat. But if you get on that boat and you measure from bow to stern and it's 100 feet, no matter what time of day or no matter what high tide you're at, from bow to stern, that boat is still going to be 100 feet. Same thing with your building. So if that building is 100 feet long and this time of day it's going to be 100 feet, but because the earth moves and, you know, gravitates and everything else, we've got differential settlement within just the civil itself. It's the civil itself. So keeping in mind that the earth is moving, and on top of that, building structures are allowed to move. So they're built to allow that same tolerance. So that's why we do have different seismic zones and things like that. So just keeping in mind, there's a whole lot to talk about when we talk about building tolerances. So the reason we wanted to drive this home a little bit is that second gen control, having that inside the building, is key and vital to everything that we do. So now, Bob, I'm going to allow you to jump in and talk everybody through measurement modes, if you would, please.
All right. Thanks, Corey. So what we've got here, guys, is this is one of the very first steps that we want to talk about when we are looking at control points. And that is the difference between high precision and fast precision as far as the robot is concerned, okay? So what high precision is that it takes a measurement between the robot and your prism or your whatever you're shooting at, a target on a wall. It's going to take that measurement 3 times back and forth, and it's going to average that for the high precision, okay? Fast precision is when we're doing layout. It goes a lot quicker. So high precision will take anywhere from 3 to 4 seconds. When you're doing layouts, you'll probably use fast precision, and that just takes one shot between the robot and the prism to go quickly, okay? Now, shooting in control points, we want to talk about our good versus our bad angles, which are happy triangles versus sad triangles. So all the time what we're looking for is as close as we can to a 90-degree angle, and we want to have equal length on that as close as possible, okay? So we just don't want to get anything that's too narrow or too wide. All right. Now going to control point sequence. So what we've got here is we've got a job site which has an existing building. We're going to add an addition to it. The existing building is down there towards the bottom of the picture and outlined in the black. And the new addition is going to be outlined in the red here, okay? So what we're going to do is we're starting off our project and we're putting our robot in the middle of the footprint of the addition, okay? So what we want to do is we want to use what we referred to earlier by Corey as our first generation control points or our civil control points. You can see they're numbered 1, 2, 3, and 4. The reason that they're numbered in that sequence is this. We always want to try and shoot our furthest distance first, okay? So we would shoot at control point number 1 first And then in this particular scenario, we would just go counterclockwise to number 2, then 3, then 4. Okay? Now, you need to start thinking in advance. So as the building starts to get more, or the building site becomes more crowded, you might have trailers, job boxes, trucks, equipment, all kinds of things that could then prevent you from getting to the control points, the first generation control points. So what we need to start thinking about is bringing our control points in and making the second generation control points, which are what we've got labeled as A, B, C, D, E, and F. All right. So we're using corners of buildings on this one, and you can see that A, B, D, and E are the corners of the new addition. C and F, we are using the control points that we would use on an existing building. So we would probably switch out of Prism mode and have stickers on the corners of those buildings and just shoot them in laser mode. Or you could create some offsets and create control points there. But the big thing, guys, is going through the sequence and doing that on a very consistent basis. So if we can, when we're using the first generations, always be consistent. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If you get to the point where you cannot see, let's say, 2, 3, and 4, but you can still see 1, always try and use that, even though we're using that in conjunction with our building control points as well. So if we can use a first generation control point, we always want to keep that in the mix as much as we can. Okay? So now what we're going to do is we're going to show you how to do some setup here, and we're going to go through a demonstration. What we're going to do first off is we're going to get to our correct model here. Give me just a second. So first we're going to go to setup. We're going to go to map. We're going to go to our job site. We've set up our robot on the job site, and now we're hitting our setup menu. Get in here. Here we go. So it's going to ask us if we want to use our previous instrument setup location. If not, we're going to over or do a resection. So the resection is that bottom left icon with the robot sitting up over the question mark. The one next to that is if you wanted to set up over a known location. But we're going to do a resection, which is our best practice whenever we can. Okay? So we are going to select our first control point. We're going up to the top left of the model. And now I'm going to move the guy over here and get him as close as possible. My driving's not the best on this, but it gives us some time to look at. See, look, this guy even can walk in space. He's awesome. But we will get it a little bit closer here. Give me a second. That control point is that circle in front of the beam, or the column there, excuse me. So we're going to get over that. We're going to level up our pole. We're not connected to, we're not locked on to our Prism yet, so we're going to do that next. So bear with me here. But as you can see, our control point is actually 0.107 there. I've already tapped on that, and we've got a circle around that, so that's the point that we will be actually shooting. So let me get locked on here. Okay, so now we're locked on. Now remember, guys, we're doing this as high precision, so this is going to take a little bit of time once we actually hit the star button in the upper right-hand corner to shoot the point. The guy moved over. Let me get him a little closer here. I'm trying to get them all on the point and leveled up here. So here we go. We're getting closer. As you can see, it's got, now you see it's measuring. It's going to take a couple of seconds to do the measurement here. And once that happens, now the control point is filled in with a blue full circle. Now we're going to move over to our next control point, which was in the upper right-hand corner. You can see the robot back there in the background where it's been set up. We're now going to level it up again. And then we're going to move over to our Trimble Field Link screen again, and we will be moving over here to the right to pick up our next control point. Need to zoom in a little bit here. Give me a sec. All right. As you can see, we have the blue circle around that control point again, and we're going to shoot this control point. Now, as you can see, our instrument position is within an eighth, and we've got good by those two control points. We're going to move to a third control point here, and let me get down there again. Driving, not my best thing here. So now we're going to collect our third control point here. We're going to zoom in, find it as control point 20. We're going to tap on that and zoom out. I got to zoom back in here real quick just to make sure that that blue circle is around it. Yeah, we're good here. So we're measuring now. And what we're going to find here is that all of a sudden our position is off 4 1/4. So what I'm going to do is I'm actually going to get rid of that last control point. So where it says included point there, we're going to tap on it, and we're going to actually get rid of that third control point. So now our instrument position is within an eighth, and we're going to go ahead and set up the machine from here. Okay. All right. So without further ado, I think Kevin is now going to talk to you about doing some measurements. Take it away, Kevin.
All right, thank you, Bob. Something I'll point out, if you guys may have noticed on that screen Bob was on there, was that you also had the rounds button down there. For some of the guys that still fancy themselves, hey, I'm the survey guy on the job site. You have the option. Then that, I believe that is actually it's a module that you can add into the software, but you've got the ability to go in there and use rounds as well. So that's going to shoot several times and average that out. So it's going to give you an even more precise position with your setup. What we want to do is we want to demonstrate the ability when we're first going in and just trying to establish ourselves and get ourselves set up. When you first walk on the job and you're carrying that yellow case, a lot of times the guys are going to expect you. They're going to say, hey, man, that guy knows how to go over here and shoot some distances for us. We've got a tool inside here under device that allows us just to do a quick measurement without even having gone through the whole process of completing our setup. And so that's what we're doing here is we're shooting our first point by going into device and tools. We shoot our first point, and it's already telling us, hey, go over and locate your second point. And so now he's plumbing up. You can see him plumbing up on that column, and he's going to go ahead and take a second shot now on this point without even having completed the setup. And now we're going to see that it's going to give us a measurement now of some 40, I think it's around 45 or so feet on that range there. Let's see what it is here. I can't remember what it pops up to be. A little bit of latency in the signal here as we're traveling across our new world that we're living in right now, but it was approximately 45 feet. I think it kind of skipped over that point. But what that does is it allows us to be able to go out there and just do a quick setup and be able to measure between columns, and then we can come in and use our little scale tool, the measuring tool that's inside the Trimble Field Link software, and we can confirm whether or not that measurement seems to be right. So then I click on a corner here of the first shot that I took there, and I go over and I zoom in and I click on my next point that's up by the other column line where I took that shot. And it's going to tell us that our range is supposed to be, I think it's going to be about, it ended up on this little virtual model they have, it ended up being like 6 inches off, unfortunately, when we did the comparison between the two. But at any rate, if you're not sure what column line you're setting on or anything like that, if you go up to device and you go down to the tool settings, you're going to find that you've got some tools in there that you probably, because it's one of the later release features, you're going to find that it's probably not something that you realize. A lot of you guys not even realize that it's in there. There's also a plumb use tool. We can go in and select the plumb use. And by doing that, we can go in and shoot the base of a column, let that laser walk right up a line there. There you go. You're seeing it there. But the plumb use is one on the left there. We can use that tool to actually walk that laser up that beam and tell us whether or not we're plumb. you're going to shoot the base point, and then you're going to shoot the upper point. So we're going to demonstrate this one more time here. We're going to measure point 1. All right, so we're plumbed up, and now we're going to take a walk. We've shot that point. We're going to take a walk down, get up on our next point, and we're going to shoot that one again. Again, these are pretty handy tools to have. And this has only been, I think this feature's been in for about 6 months, maybe 8 months, where we could go out and just without even having completed the setup, take a shot real quick, just to get some quick measurements. And if you think you know where for instance, you think you know where your transformer pad is supposed to be about, you can just take a shot over there and see if it makes sense. All right, so now we're going to get up on top of this control point, and or this next point. It doesn't have to be a control point. Just take a quick shot here. Get him on top of the point there, and take a shot. Hit the top right corner. All right, we've lost him there, but at any rate, so that's how we're going to use the measure tools and the plumb tools, okay? So what I want to jump into now as well is getting into the ability to go in and create data on the fly, so that we can, if we need to, we can incorporate some, like we talked about, the building control points. If we want to go in and create data around one of our column lines, we can use the tool that's up inside the software that's going to be the patterns tool under the create data tab there. And we're going to get to that in just a moment here. Let our guy kind of get caught up here. He's still going on and measuring some stuff. But with the ability to do that, we can go in and we can set an offset, whether it's 1 foot, 2 foot, 3 foot, whatever we can get to on our column lines inside the data, inside the software. You're going to be able to see that in just a moment. And we can hold off. I think a lot of guys will hold off around 4 feet, and we can hold off and set those points all the way around that column. And then once we've created that pattern, we can walk around the whole side and drop that pattern in on all of our columns, so that we can then go measure those and use those BCPs, if you want to call them. That's a second generation control that we've created on those columns. So let's get into doing some of that now. There we go, 45 foot 6 inches. That was a long way around there, but again, we're seeing where we kind of got those points on the deck there that we were using as a reference to try to get an idea of what we wanted to make sure that it made sense, right? So if we go up to create and we drop down to pattern down here, this is what we were talking about, so that we can actually create our building control points, or our second generation control points. So if you look on the bottom left, you can see that that's where we're going to actually be creating using the grid work here. Each one of these blocks represents 1 foot, okay? So we're going to, if we go in there and we've already got a pattern created, we could actually just load it at this point. But what we want to do, though, is actually go in and create one. So we'll go back up, and we're going to hit the create button and go back down here, okay? And now, so each one of these grid squares is a 1 foot pattern. So what you're going to see me do is just kind of bounce over and start counting these things. I'm going to go in and create a 4x4 pattern. That seems to be pretty common. So I'll just count over 1, 2, 3, 4, and we're going to drop a point in there. And we've got another one top we'll drop in the other quadrant. And what happens here is the center point that you're seeing there, the cross in the center, that represents the column line intersection. So when we are ready to go place this point, we're going to use that center point as our reference location to drop that on the column line intersection. And so now that we've got our points in there, I'm going to hit the add points button there, and I'm going to hit the save pad. And it's going to prompt me and say, what do you want to call it? I'm going to call it 4 foot offsets for column lines. And I'm going to, as soon as I get that, I will save the pattern. And now I've got that pattern saved. Once the pattern is saved, you can see there's multiple patterns in there. We can go and start placing this pattern, okay? And so if we want to, we can create all these patterns before we ever get out to the job, put them on the tablet or put them up in Trimble Connect. And by doing that, they're all loaded and ready for our field user to go out and go to work, okay? So it's a pretty handy tool. All right, so I just loaded that pattern back in there. So it's now ready for me to go in and start placing this pattern. So I'm going to zoom in and get up on top of one of my column line intersections here. Start in the bottom left corner here, getting kind of close. And you're going to see that I'm going to select that center point. When I select the center point, what you'll see is it will automatically project those points where they're going to be. All right. So let's select this guy right here. Looks like it's grid 10. And when we select it, we can see that where the control points are going to be, the building control points, if you want to call them that, second gen control points are going to be projected onto the deck. We'll go up, okay, select that guy. And there they are. Now they're showing up. And I can go in here and name these guys. I can put them in their own layer, which is what I'd like to do. I think it's important that we remember that we want to manage all of the data that we create, okay? So I've created that thing inside the control layer. All right, and then we'll hit create. And then we're going to see automatically that the numbers are there, everything that we're going by. So we're going to start this naming convention. Let's start it with, I think I called this control layer, CLOS. There you go. And we're going to put this down in here in the layer. That's going to be the, I think it's the CLOS layer. I also recommend that you can see there, I've got a little dash or something in the front there. You can do an underscore. What that will do is that will pop your layers to the top. Okay, when you're managing that layer, it's going to pop it to the top. And you can see now we've got 1,001, 2, 3, and 0. So those points have been created, so I can bounce around the whole job now, creating these points. Here's my second points that have been created, and you can go in and see when I hit the information tab, I've got a 1,000 through 1,006. We'll go around the job here and create some points. And again, I could have just created 2 of these points instead of doing them on the outside. I could have just created, because those are out in space. They may not be of a lot of use to us. But I'm going to bounce myself around the job site here and create my second generation control points. You'll see those popping on the screen on occasion here. Get back in here and create some more. On an already cluttered job site. So why it's so important to be able to manage our data, turn off some of the layers when we don't need those. If you're one of the data prep guys, project manager, BIM guy, VDC, whatever you want to call yourself, you're inside the office and you're creating this data for your field guys, keep in mind the layer management, okay? And again, if you hit underscores in front, when we hit that layer tab over there on the zipper on the right, it's going to pop all of the layers they're most interested in to the top so that they can find their stuff quickly without going through the other 98 layers that were brought in by Revit or AutoCAD or whatever file authoring tool you're using there. Software authoring tool. Okay, so we're going to create a few more here. So we're still just moving around the site here and creating that data. Okay, and so something else I wanted to kind of hit on while we're talking about this is talking about the reference elevation. Okay, so we're getting ready to move into that a little bit more here in just a moment. But with regards to the reference elevation, if we've got a known location on the job site that we know that we've got our confidence in, that is a known elevation. Benchmark, obviously, a lot of people refer to that as a benchmark. Our extra intelligent, super experienced survey guys are going to come in. They're very vital, very important to what we do out on the job. They're going to come in and set some of those base locations for us. And by doing that, they're going to give us some solid points that we've got confidence in, okay? And that would either be a benchmark, it might be designated as a benchmark, or it might be another point that we're using as a reference point that is known by the project manager, the GC on the site, okay? So we've got this reference elevation that we're going to use. We want to be able to occupy that location and be able to set up and take a shot on it, okay? So by doing that, we're going to go into the software and we're just going to go up to devices, and we don't have a slide on that specifically, but we'll go up to devices and drop down. There's a reference elevation tab right there. All we're going to do is select on that tab. It's going to prompt us to take a shot exactly where that prism pole is sitting on this known point, okay? And if our elevation is 584.62, whatever that is, we're going to dial that into the input form, 584.62. By doing that, and then we're going to hit the measure tab, that's going to associate that instrument height and that actually the prism height to that elevation. It's going to then, as we walk around the job site, it is then going to give us corrections to get back to that known elevation that we're looking for. Okay, guys, that kind of brings us into the tips and tricks part of what we want to talk about today. And as we get into this, identify your first and second generation control points. Again, we talked about those being the civil control points versus the building construction points, okay, building control points. But what we want to always try to do is we would like to try, as we migrate over and start getting inside that building, we want to try to incorporate one or two, if we can, of our original civil control points so that we stay grounded and we're staying on that grid that we've got associated on that job site. So keep in mind about that. We also want to get into when we talk about triangulated setup, we want to make sure that we're using that happy triangle so that we're getting good geometry that we like on that job site, okay? And if we can do it, if we can use our third and fourth control points, we want to do that. Remember, Bob talked about turning off one. If it gives you a bad solution, that one might be the one we want to avoid in the future. That might be the one that's kind of kicking us out. So we can turn that one back off and not use that one, okay? We want to stay consistent when we're shooting our control points, as in we want to try and maintain our organized pattern of going around and collecting those control points and establishing our setup, okay? So that when we're out on a job site and we're setting up, if we're going to go 1, 3, 4, we want to continue doing 1, 3, 4, and then associating that back into the building control points as well. So just try to maintain that pattern, maintain that consistency in the way you're shooting those control points, all right? Communicate your intent. I think it's a really good point that we want to hit on. Communication is so important on that job site. I've gone to a lot of job sites and I hear this group, maybe it's the mechanical guys, are using their own control points that they've set up. The general's using these control points. It's so important as the general to lay the law down on that job. When those guys on the job site and you're having your update meetings, we need to establish control on that job. We need to make sure everybody's using the right control, what is designated. And by the way, if you're the user and you start to suspect something is wrong, you need to beat the drum, man. You need to make sure and tell everybody, hey, man, something's going on with our CCP over here, our first gen control point, whatever, maybe an excavator or something rolled over top of it. That one seems suspect to me. Beat the drum on that and let those guys know that something's going on. Share that information with all the project stakeholders so that everybody knows and everybody's on the same sheet of music, all right? Communicate those errors and let everybody know real quickly on what's going on with that. With that, I will turn it back over to our fearless commander. Go ahead, Corey.
I'll add in a little bit too with the building control points. Just if you're a second or third tier contractor on that, and the general is not providing building control points on the different floor lines, have that conversation with them, and you know, feel free to reach out to us. I can share the spec data that we just found for why you need to have that, but keep that in mind as well. That should all be part of the communication that y'all are talking about together. We've got quite a few questions in here, so we'll talk about those here in a minute. But just wanted to talk through, we've got a whole lot of resources that we've talked about with all these. This is our 5th webinar now, but on our YouTube channel, for those that haven't caught on yet, every one of these webinars, we take them and we process them, record them, clean them up a little bit, and cut out all the ands, ums, and uhs, and make us look a little bit smarter. We post those out on YouTube to make it a little bit quicker and faster. On top of that, we've over the past few weeks, we've been posting a lot of 3 to 5 minute videos that are quick starts on how to level your robot or how to do this feature and different things like that. So we continue to do that. So keep that, save that as a resource. If you haven't followed that channel, I highly recommend that. That way you get notified when we do add new uploaded videos to that. They're also on our website as well. If you've not yet done so, learn.trimble.com. A lot of free courses through Trimble that not only do you go through courses with an online speaker, it might be video recorded, you also get a lot of material on top of that. So you get user manuals and things like that that are put together by Trimble. Great resource. And again, it's a free resource for you. So there are a few paid classes on there, but by and large, I think it's about 90% of them are free classes that Trimble is trying to do like we are, just educate. Next slide here. I apologize for the there. This one of them we'll filter out, is who our team is. So on the presentation here, we've already got Bob Groen and Kevin, and they've presented before. I think you guys know them. Kevin covers our Kentucky and Tennessee area. Bob covers Missouri and Arkansas, and then we've also got Charlie Kim up in Nebraska and Kansas. And then if you're outside of that territory by any means, and you're on this, you didn't miss or click the wrong link, you got the right people. However, if you're outside of our territory, the biggest thing that we want to do is make sure you're getting good help. So please reach out to us. That's why we got Kevin's contact information out there. Kevin will put you in touch with the right person. So instead of having to guess or go through a 1-800-TRIMBLE number, you can go direct to us and we'll help you find that resource. So now we'll jump into Q&A, and we've got quite a few really good questions here. So I think the first one, Sean, I'm gonna call you out. You've been really quiet this whole time, so I think everybody needs to get to know who you are. So this first question came from John, and it's, will we be addressing the difference between U.S. survey and international feet? And Sean, I know, and for those that don't know, Sean was a land surveyor before he came to the dark side, so I'll let him answer that. So Sean, go ahead.
So I would first preface, I hope you never get into a project that is using international feet. But on rare occasions, they do get built or designed in international feet. And there is a difference. I think, if memory serves, it's around an inch in 40,000 feet. Somewhere in that neighborhood is the difference. The problem is usually you use larger coordinates, larger format coordinates. So when those coordinates get into the millions, you multiply that 40,000 or divide that 40,000 by a million, and then that's going to give you the number of inches that you could potentially be off by. I will say that Trimble FieldLink software does not have a setting for international feet. It is only a settings for inches, U.S. survey feet, and meters, and that's it. So if you run into a project where that is, it was designed as that, I would say you might need a different software if you have to lay out in that regard. But I would always challenge anybody that sends you data, anybody that sends you any kind of data whatsoever. I would challenge them and just ask them, is this in inches? Is this in millimeters? Is this in feet? Is this U.S. survey feet? I would challenge where you get your data every single time. But I would never, ever, in the history of ever, use international feet to do layout.
Very good. So this next one I'll take, but I'm going to kind of open it up to the whole group here to jump in and save me if at any point in time. But the question is, we've seen other contractors use reflectors mounted on other buildings. How do we set those up? So we've got those reflectors as well. Trimble offers them. As far as setting them up, all it takes is, and again, the practice that I always like to follow, and I did this as a GC, is I would set up building corners based on survey control. And then what I would do is I would go find those adjacent buildings and I mounted reflectors to them. And then after I mounted those reflectors to them, I tried to screw them in if at all possible. Double stick tape will work, but just make sure it's not going to move. I'd place them up, and then I'd set my robot down. I'd shoot my control points for my civil control, and then I would go up to collect. So in lieu of going to layout, I'm going to go up to collect, and I'm going to shoot my laser up to that point up in the adjacent building and aim it at that target, record that data, and that's going to give me an X, Y, and a Z that's going to be associated with all of my civil control points on my X, Y, and Z. So that way it is spatially located to my site, and then you can save those back and share those as additional control points. Again, just title them as building control point or a second gen control point at that point in time. And Sam, I know that was your question. If you want to dive further into that, feel free to give us a holler. Kevin, I think you've got something to add to that.
Yeah, I do. I think that was I'm going to let Sean clean all this up, but I think that was an excellent explanation of what you just did there, specifically with the RPT. A lot of guys use the RPT reflectors that way. That might be the tool you're thinking of. But the thing that I really wanted to add was that, remember guys, within the Trimble FieldLink software, you're not restricted to only one or two prisms. If you know that Prism Constant, you can come in and you can use that. So when we talk about reflector or a prism, we can put that Prism Constant in there and tailor it to your peanut prism or whatever you've got. And if you go out and you mount these 360s all over the buildings or whatever, just make sure you're using the proper prism, that you select that proper prism and that drop down and then go to work. Sean, if you want to clean up.
That reminded me, Kevin, if you don't mind, I'll hit this one. Sorry, Sean, to interrupt you. Just make sure that your settings. So with a lot of our layout, we've talked about setting up to your prism, be it an MT1000 or a 360 prism. So you pick custom foil or custom prism at that point in time and identify that. So what Kevin's talking about with the constant, it's the same thing. Just make sure you've selected for the right target, because that also may change how the laser shoots at that. So different intensity, whether it's hitting a prism or a reflector. So Sean, did we do okay with that one, or you have something to add?
No, all great answers. The only thing I would caution customers is once they get to a certain height in the building, I would highly caution against using reflective targets once you get to a certain height in the building. And that height could be 5 stories, that height could be 40 stories, but at a certain position up, the building's going to move quite a bit and sway too much, and then you're going to introduce air into the project if you're using control points off the building. But if you're 1, 2, 3, 4 stories up, I wouldn't hesitate to use any type of reflective prism or reflective tape on other buildings as control points.
Very good. And I would add to that, Sean reminded me of a point. I was on a job that somebody put those on a parking garage that was adjacent, and they put it in the middle of the spandrel panel. And depending on the time of day or what size the vehicle was that drove by that spandrel is going to change. So keep that in mind too. I'll just kind of throw out my advice is parking garages, unless you're putting it right in a corner or right on a column, that's a bad location to put those targets. So just be smart about where you're putting those. If you can't put it on a corner, on an inside or outside corner, or right where a column is, that's one of the best places to put those. So the next question here, I'm going to move on to the next structure.
I'm sorry, I was going to jump in on that. I was going to kind of allude to what Sean said there real quick. So Sean, as you're going up through that structure, you're saying be cautious of that. So I think what you're alluding to then is we're going to go back to the BCP or the building control points, and we're going to start using those internally in that structure as much as possible.
Yeah, on a lot of the projects like we see down in, let's say Miami, where we're running 50, 60 stories tall, it's not feasible to set up on the 45th story, shoot down to the deck or down to the ground elevation, and bring control vertically. And in most cases like that, most of the concrete, the GC guys, they're using very high accuracy vertical lasers that literally their only job is to shoot a plumb line up and down. It'd be no different than dropping a piano line or a piano wire up, down an elevator shaft. But they're using these, and they're putting sleeves in the floor that repeat all the way up through the entire length of the building, and they're using that to control the building horizontally as well as vertically, but mostly for the horizontal side of things. So there is no answer for how high do I have to be. There's not a good answer for that. My answer to that would be, depending on how your control is checking, the more vertical you get is when you're going to have to make a decision that I need to stop using control outside of the building and start using only control inside of the building.
Very good, thank you. So the next question came from John, and this is, how do I approach the difference between northing and easting and XY coordinates?
So I can answer that. So northing and easting is exactly the same as XY. It's just YX. That's the only difference. There is not any type of difference between the coordinates or the coordinate values. It's literally, if you put it in an Excel spreadsheet and just listed them out, 0.1, 2, 3, 4, 5, you could have N or northing, E is an easting, and then the N part of that is the Y. The easting part is the X. So you can flip-flop those around, but just know that before you import data into your tablet, just know the data that you're bringing in. Make sure that data is northing easting, or if it's XY. And before you import that data, make sure you have those settings set up correctly on your tablet to ensure that it comes in the right spot and not everything's mirrored or flipped in the wrong area. So it goes back to challenge where you're getting your data. Ask those questions ahead of time. Is this data XYZ, or is it northing easting elevation?
The next question is, does FieldLink allow you to take direct and indirect measurements, aka phase 1 versus phase 2?
So the answer to that is yes. So in the control module, it allows you to run a traver similar to what a surveyor would do. that will allow you to measure rounds. So you could do face 1, face 2 on your back sight foresight. You could do face 1 in vertiscope, face 1 on your back sight. Turn your angle, face 1, face 2, and then you could just repeat that process multiple times until you wanted to do 3 or 4 rounds to be able to complete. And what in a surveyor's world would be is running a closed loop or running a traverse. And then at the end of that, you can run a network adjustment against that data to be able to confirm that what the traverse that you ran or the control points that you just shot in, to what degree of accuracy are they in. It's a least squared adjustment.
Very good. Next question, and this is if working inside of an existing space and you don't have access to any surveyor points where the GC is not going to hire a surveyor, what's recommended to establish control? So I'll let them answer in a minute. One of the things that I always recommend is finding column lines. So if you're inside of that existing space, you can't get to a building corner, a column line. And that's where Kevin was showing that offset of being able to set up a pattern of 4-foot offset of that. Sorry, I can't talk. But that's just allowing you to be able to come off 1 foot, 2 foot, 3 foot, or 4 foot from that column center line and bring those out a little bit. I don't know, Bob, Kevin, or Sean, if one of you had something else you wanted to add to that.
Something I like to go back to, and this sounds like this might be an interior build-out type person asking this question maybe, but you used to take a tape measure and you use something on the deck to reference that. You're professionals, so you knew what you were doing. You've got a job, you know how to do it. And so, yes, column line intersections, sometimes you might not be able to get that. So if you're hanging something inside a building, inside a wall, or inside a room, you might just use a simple resection, which is not ideal, but it's going to do as good or better than a tape measure would do. Maybe you've got a 50 by 50 room and you've not got anything else to measure with, but if you've got a plan there and you know this corner and this corner, that's what you're going to do with your tape measure. If I've got a lot of points in that room, I'm going to use those corners if I need to, just as a quick reference, a quick layout. And I'm going to do as good or better than I would have with my tape measure, except a little more quickly.
I would add to that some of our customers, depending on who they are, I mean, they're in different stages of of having that similar problem. If you're walking into an as-built location, we've got some customers that have laser scanners. They'll literally just go out to the field, scan what's existing so they can bring it into the model, and then align the model accordingly to make sure they have the best fit possible. Otherwise, you are pretty much stuck with using anything existing that matches the CAD file. That would be the key. Any type of column line, building corner offset, any type of anchor bolt, anything that you can match in the field and match on your drawing to align your drawing to current field conditions. And then the secondary part of that is you got to find something that checks, or find an error that you can live with, an eighth, a quarter inch, a half inch. Find the error that you can live with, but then lock it down. Once you find that result, lock it down, set new control points from there, snap chalk lines, do whatever you can to maintain that level of control for the rest of the building.
Very good. Thank you, guys. This next question, and I know every one of us has got experience here with this, but starting a new job in a downtown area, the general contractor has established control using reflectors only, and they're set up high on adjacent buildings. Can I use my RTS 873 to shoot them, as that has no way to dial those in?
So immediately, no, it's all right. Immediately, the answer is yes. You can use your RTS 873 to take those measurements. The downside to that is the 873 has a high accuracy EDM built in, and what that means is we restrict the range that it can shoot with the laser to maintain a higher degree of accuracy in distance. So there is a certain point away from the 873 where you cannot collect data, and it's similarly with the 773 or the 673. We do have one model, the 573, that allows you to shoot a ridiculously far away with a high degree of confidence. The other downside when you're doing that type of setup and layout is the 873 only has a video camera. There is no scope to look through and focus through. So that is a small problem. I would guess your local BuildingPoint sales rep, Kevin, Bob, or even Charlie, I'll bet they have another instrument that if you need to set up that day and set a couple control points that you can do on your own, basically bring that control onto the building, I'm sure you could probably borrow, rent, or loan that robot for that day to set your own control to be able to do your layout for that particular deck. And if it becomes an issue, if you have to do multiple stories, then I would suggest, maybe you need to rent a different robot for that particular project, or I don't want to say you have to buy a robot just for that one project, but I think there are other options that you would have to consider. And an 873 is a tool in the toolbox, but it can't be your only tool sometimes.
Very good. And as Sean hit on, we've got a couple of customers. That's why I kind of shook my head a little bit when we've experienced this. We've done that exactly, where the customer says, man, I can't use this. And, we get them the instruments that they can use free of charge. And a lot of times what we did was okay, let me take your gun and hold it for collateral while you take your gun. So keep in mind, if you're experiencing that, let us know. Call Kevin, Charlie, Bob, and we'll be happy to kind of work that out. So this next question, Sean, I'm going to ask, there's two questions that are very similar, so I'm going to ask both of them, and I think they're great questions for you to answer here. So the first one is, what are your best tips to have confidence in your control points? And the second question is, we had mentioned ignoring control points that we got out of a tolerance setup. How do you know that it was the last control point and not the earlier points? So how do you verify whether it was a Gen 1 or Gen 2, or if that control point had moved at some point in time? So, Sean, you're probably best qualified to speak at that, so I'll give it to you first.
So every project's going to be slightly different, obviously. It's very rare that you're going to have a situation where all of your control points check all the time. I would say, to answer the first part of that question, is hire a good surveyor to set control for you. That would be my first inkling. Not to say that they're not using any different type of a robot than what we sell. The survey instruments are the same accuracy as the RTS robots that we're selling. So there's no degradation in accuracy between any of the products that we sell. It's simply workflow, and it's something you're going to have to. It's an acquired taste. It's going to take some time. But there's I would say step one is to hire a surveyor. To be able to maintain control is a common theme across multiple projects, and I would start with things like make sure your robot's in perfect calibration. Do field calibrations. If you can't do it daily, do it weekly. If you can't do it weekly, do it monthly. But do those field calibrations. That will greatly increase your chances of maintaining higher level, higher accuracy control points. Calibrate your Prism. If accuracy is the utmost and critical thing on your project, maybe consider using a tripod base, a tripod backside setup. Use tripods with a tri-brack and then a Prism on top of that. That's going to give you a higher level of confidence that the points that you're measuring are of the highest accuracy. Step two is usually shoot your control points as soon as you get done setting up. Don't wait till the end of the day. You've been set up for 3 or 4 hours and you haven't checked anything. You've just been doing layout and you're like, oh, I need to shoot a bunch of control points. Shoot your control points right away. Make sure your temperature pressures are set properly. These are very small things to check and to have, but small things equal bigger things. And if every time you set up the robot, you set a new control point and then you move, you're adding air with each setup that you go across the deck. And so if you're doing 10 or 15 setups, you're adding air every time you potentially set up and shoot new control points or add new control points in. One of the highest accuracy ways to do a setup is to use the laser pointer. It is to be able to sight with the crosshairs, sight an object, measure that object, and you're essentially using angle-only measurements. But that's probably the highest level of accuracy to be able to take to shoot your control in with.
Very good.
And then what
Good
was
answer,
the
Sean.
what was
Thanks.
the second? I was going to say there's probably a second part. He could probably, if you wanted to, put my contact info in there, and I'm happy to answer that question with anybody.
Yeah, I'll do that. And to reiterate, the other part was just how do you know which control point was off? And you pretty well covered that by saying go back and back shoot those. So once you're set up, shoot to that control point and then shoot to the next one. So I know, Sam, that was one of your questions, was how do you verify? The way that I've done it in the past was when I know there's an anomaly or something's off, you get your setup done and then you shoot back to the others, and it's going to tell you which one's off. And then you can flag it from that point. The next question that just came in was how to lay out a radius without using a radius point. Can you use down and out laying out a radius?
So laying, the problem with
you
that
can,
is,
right? It's about accuracy.
Yeah, you're missing a key component when you're trying to lay out a curve or an arc or any type of curved surface. If you don't have that radius point, that's pretty tricky. I mean, you can create an arc between just 2 points, but you don't know how much that arc has to bow or how shallow that arc needs to be. I mean, certainly you can use Trimble Field Link to calculate the curve, and then you could offset that curve. That's not a problem at all. But if you don't have enough of the information to be able to calculate that curve, I think you're kind of stuck in the mud at that point. You need one more piece of information there to be able to accurately lay out any type of curve.
Very good. And I'll add, depending on if you've got a CAD drawing or something like that that has the curve identified, depending on how that curve is identified, you can, and as we've covered before, and we're going to talk again here in a couple of weeks, just how to create data. If you're using Trimble Field Link, you can, and it's a true radius, as I spoke about earlier, you can find that point. If it's a segmented line, you can use the segments and have lines within each segment. So it's not ideal. However, that is one point where when a CAD technician gives you a segmented radius instead of a true radius, it does allow you to create a little bit better control points for yourself using those segmented lines. Kevin?
Yeah, and I'll pose this because I like this part of our seminar because it's a little bit of a freelance discussion here. But Sean, suppose you're setting up on top of that radius point, and then you're going in and you're turning, if you know what that degree of a turn is, and you're turning and laying out in that manner at a distance, probably using laser mode.
Sure. Yeah. I mean, you obviously, if you could set up on the radius point, that would be ideal. But that gives you that third piece, right? That third piece of information that you would need, right? Because that you would then know your radius distance. You would know where your point of curvature is, or starts, or point of tangency starts, and then you could use that and then kind of backtrack it over to the next point, or the wall, or the foot, or whatever it is that you're trying to lay out. So you really, to be able to lay out a curve, you would need a few points of information. If you don't have it, you've really got to make a phone call and call somebody to find it. Yeah.
Gotcha.
Yeah, it's risky to fake that. So great point.
Okay.
So the last slide here is just our next upcoming webinar. I know we've been doing these every Friday. We're going to skip a week. So we're going to go out 2 weeks, and then on May 15th, we're going to dive in a little bit deeper. I know a few weeks ago, Sean Thompson did one on Trimble Field Link software. We're going to dive in a little bit deeper and show the user experience of creating data, importing data, all within Trimble Field Link from your tablet. Not having to go out to Trimble Field Points. We will have a future one on Trimble Field Points, but we're just going to dive a little bit deeper into Trimble Field Link and what's on the tablet and how to start creating points, how to add lines, and a lot of what we talked about today, we're going to show you that way. So working through the software a little bit more and how to add points. So as we've covered in the past, if you get a point file and a model from somebody in your office and you wanted to add a point because they always forget that one point, we're going to show you how you can add those yourself and be able to push that back into the office afterwards. So again, May 15th. This same time frame. We look forward to seeing you all there. Again, we thank you all for being in attendance. Sean, thanks for joining us today. Sean's in dreary Florida, so that's terrible. We'll allow you to get back to the beach. But thank you guys very much. Have a great weekend, and be safe, everyone.
Sean's got jams on right now, I'm sure. So, thank you guys.
I'm wearing flip flops.